two problems, one for finding out level of service of freeways, the other one for finding out level of service for multi-lane highways. Okay, then we reached till this one. This is a design problem where we have to find out the number of lanes. Okay, so they gave us how much volume they are expecting in the future. Okay, design directional design ability volume, peak hour factor is given, percentage of trucks is given. Okay, total run density is given. So we didn't find out the free flow speed. Okay, we should have done it first. Okay, so let us begin with finding out the free flow speed, and then I will ask what I ask you to bring. Okay, free flow speed of the freeway is this thing. Okay. Now FLW is a factor for lane width. FLC is a factor for lateral clearance. Okay. Are these values given in the question? Lateral clearance and lane width, are they given? And what is the reason they are not given? There is a reason behind it. They cannot give it. And why is that? Huh? It's new highway, right? It's not existing. So how can they give for something which they are designing, right? So what do I do then? Huh? Yes, you will assume, right? Okay. Now if you are designing something and you don't know any dimension and you have to assume, from where would you take this assumption? You will assume any value? From where do you take the values of design?
Old design.
Huh? Old design. And from where they took the value in the old design? Huh? From the code or standards, right? There are some code or standards that we follow. Okay. If you go to the, I will not go there. Okay, but if you go to the table where the factors are given, they have given you standard values. The standard value, the factor becomes 0. These are adjustment factors, right? So if I take the standard value, no adjustment. Okay. So you can go to those tables and see when these factors become 0. You can see the value, standard values there. I believe in one of the slides I wrote them down, maybe. I'm not sure. But anyway, if you go to the table, you will see when the factor becomes 0, the value at which the factor becomes 0. Now if I have to assume, I'll assume what? If I have to assume a value, I'll assume what? Which value will I assume? 0, standard value, right? The standard value will make the factor 0. Okay? So these factors are 0. Okay? TRT is given. Give me the free flow. 0.8, 74.8. Okay. Yes. Yes. I had a doubt. TRD is 0.5, huh? So 3.22 into 0.5 to the power 8.84. The guy on 6 wheels.
Sorry?
The guy on 6 wheels.
Yes.
We're counting
Sorry.
wheels for this, right?
Sorry?
We're counting wheels for this thing, for the chair. Right? Okay. Now, so we found the free flow speed because in these analysis, always find the free flow speed. The first step, is always to find out what? Free flow speed. Okay, this is the first step we do. For the second step, we are actually going to use this equation to find out the number of lanes. We have to use this equation. Okay, DDHV means the volume, the forecasted volume which is given in the question. Okay, peak hour factor, it's given. FHV, this is the thing which I asked you to come with. 3 FHV values. Tell me. We need FHV for the level terrain. We need one for upward gradient, one for downward gradient. Yes. No? FHV values. Nobody has it? No? Okay, that's good. Congratulations. We will finish early today. Anybody has it? 9.3? Wrong.
3.1.
Very good. Extra wrong. Anyways, congratulations. We will finish early today. Okay. So we have a 6-lane urban freeway, okay, and it has a major free flow speed which is given, rolling terrain, only 10% trucks, all conditions are standard, so no adjustment factors for capacity and speed. Okay, peak hour factor is given, the current traffic volume is given, okay, for one direction, and this volume is expected to grow 6% every year. Okay, this will grow 6% every year. Okay, for how many years? 20 years. Okay, so this is not 6% total of 20 years. Every year the value will change by 6%. For the next 20 years it will keep on changing by what percent? 6%. Clear? Okay. So we need to find out the level of service of this facility now. So now how much is the volume? It's given. Okay, for now it's given. But they are also asking for what will be the levels expected after 5 years, 10 years, 15 years, 20 years for the same highway. For the same highway. Now for now, I know everything. For 5 years and 10 years and 15 years, which value is going to change? The volume will change, right? And volume changes by how much amount? 6% per year. Okay. So how do I calculate volume after 5 years? What do I do? Yes? Huh? This is not from last time. You were here last time, means what? I was not here last time, right? Yesterday I was not here, right?
This volume was increased.
I'm losing hope in this. Totally, right? I was not here last time. Volume is increasing, but decreasing. Yes.
This volume was 30%.
Huh? How did you get 30%? 6 times 5 is 30%, right? 6 times 5 is 30%, right?
Wrong?
Even he was not here last time. Yes, you are wrong, obviously. This is wrong, but at least you can say this much. I was not here last time. Were you not here when you were in the school or not? Okay, anyways. So, yeah, this is one of the ideas that you take, 6% for every year. So, in 5 years it will be 30%. 30% of what? 30% of the current value, right? Okay, now this is where we have the problem. Any other ideas? Yes. Exponential, okay? This is simple growth, which is assuming that every year 6% of this value is increasing. Okay, this is simple growth. Okay, this is simple growth, where the initial value is constant. Okay, in this case it is not constant, because after year 1 the volume will not be 3600, it will be 3600 plus 6% of this, right? And after year 2 it will be 6% of the new value, not 3600. Got it? Okay, so this is called as exponential growth approach. So in exponential growth, the future value equals to present plus this, where f is the future value, p is the present value, which we can keep now 3600. Okay, I is the growth rate, and n is what? Number of years. Okay, so using this equation I can calculate volume for 5 years, 10 years, 15 years and 20 years. Tell me the values. The present value now we don't have to change. Okay, we will keep 3600 if we are using this equation. Six four four. Yes. 8628. 11546. The growth rate. Okay. Any question? Any problem? He's a good teacher, huh? Yes. Okay. Now you know the volume current. You know the volume 5 years, 10 years, 15 years, 20 years. Okay. How to find out the level of service? We have already covered it last time. Okay. The example which we did, both examples were to find out the level of service. Okay. You can apply the same procedure. Okay. Except you were not here, obviously. So everybody else, more than half of you were not there, right? This section was empty. I remember now. Okay, so you can do the same procedure with a different value of V. Okay, so the whole thing will remain the same, only the value of V will change. Okay, so this can be done. So you will do the whole thing how many times? 1, 2, 3, 4, 5 times. Okay, each time with a new value of V. There is no problem with this approach and you can do it. Okay, clear? In this case, and this is for your practice, okay? You consider them as 5 questions, 5 practice questions, and you can do it, okay? And look at the previous example if you want to have an idea. For the sake of the class, we will do it using maximum service flow rates, okay? Okay. The free flow speed in the question is 65. How much is it? 65. Do you see a curve here with 65? There's a curve with 65 value. Okay. I'm going to explain how did they plot this curve. Okay. How did they plot this curve? You see, what is 65? Free flow speed. Okay. So if you know the free flow speed, you can plot the first point, right? You can plot the first point. Okay. What are the coordinates of the first point? Tell me now. X and Y. 0 and 65. Okay. 0 is the X value. So flow is 0 and 65 is the Y value. Clear? After 65, how does the curve move? It's a straight line. Okay. So for this straight line, I don't need any new value, right? I will start from 65, make a straight line. Okay. Clear? but a straight line goes up to a point, right? After which it goes down. Okay, what is that point? What is that point? This one, right? We call it a break point. This is called as what? Break point. Okay, so if you know the value of break point, then you know the last point of your straight line, right? Okay, so it starts with free flow speed, then you keep on going until you reach this point. Okay, how do I get this point? There's an equation. If you have a freeway, if you have multi-lane highway, then clear? Okay, so the first point was 0, 65. Second point is what? What are the coordinates of the second point? Tell me. First point was 0 and 65, right? 0 is x, 65 y. What are the coordinates of the second point? Break point and 65, right? Till the break point is a straight line, right? So speed is not changing. Okay, and the flow is how much? Flow is equal to break point. Okay, clear up till now? Any problem? Okay, let me write it here. So I will call it point 1. Point 1 is 0, 65. Point 2, break point 65. Okay, clear up till now? Okay. After which the curve goes down, right? The curve goes down. Okay, it goes down up to what point? That's it. Okay, now what is capacity? X or Y? Capacity is X or Y? You are asking me why, or you are saying why? Why? Okay, very good. Wrong. X. Capacity is the flow rate, right? Maximum flow rate. So capacity is the X. Okay. Do I know the Y at this point? I don't know. Okay. Can I find it? Yes. There's an equation for it. Okay. There's an equation. Now what do I need in the equation? I need free flow speed. Okay. Free flow speed, we know, right? For this question, we calculate the free flow speed. Oh, sorry, it's given. Sorry, it's given. If it is not given, you can calculate it, like I did for the previous exam. Okay, you can calculate. What is this capacity? This is what? Capacity. I need capacity here, right? Capacity is my X value, so I need capacity in any case. So from where do I get the capacity? If it's a freeway, this equation. If it's a multi-lane highway, this equation. Okay, so you need capacity. Capacity is taken from here. Okay. What is the next thing I need? DC. DC is critical density. Critical density, which is fixed. Okay, critical density is density at capacity, which is fixed, 45. Okay, what is BP? What is A? It's a constant, it's given here. For freeway and multi-lane highway, given. Okay, now what do I need here? VP. Okay, VP is flow rate. VP is flow rate. Where is flow rate in the graph? X-axis. Okay. Now I'm trying to find out the speed at which point? Okay. My VP equals to what here? Capacity. Got it? For this point. For the last point. For the last point, VP equals to what? Capacity. So this will remain as it is, because this is capacity. This is equal to capacity because of what? Because I am doing it for the last one. Clear? Clear? Okay. So this VB is the X value from the graph. On this point, the X equals to capacity. So that's why I'm putting Vp as capacity. Clear? Clear? Okay, so this will be, I'll not call it point 3. I'll call it point C. Okay, so what are the coordinates of point C? Capacity, okay, and S at capacity coming from the equation. Okay, so put Vp equals to capacity here, and whatever the value of S you get, that will be the y coordinate. Clear? Okay, so I know point number 1, origin, or the x-axis or the y-axis. Then I know point number 2, okay, and now I know the last point as well. Can I draw the graph? Can I draw the graph? Yes, we can draw it, right? We are engineers, we can do anything, right? Whatever we feel like. Yes, we can, right? No? The people who say no have to give me an answer then. Why no?
Then yes.
See, easy. Which is wrong? Tricking you guys is very easy, right? Huh? He says yes. Ask him. The big guy behind you. Huh?
To be honest, I'm not sure.
Huh? Yes.
Oh yeah.
Sorry, I woke you up. No, we cannot. Okay, it's a curve. If you make 2 points, so how many points you know for the curve? I'm not talking about the straight line. The curve, you know 2 points. One is the BP, the other one is capacity, right? If you join 2 points, you will make what? A straight line. Is it a straight line? No, a straight line doesn't have these type of weird equations. Okay, so it's not a straight line, it's a curve. To plot the curve, I should have more points. Okay, now to make more points, I will need x and y values, right? X and y values. The equation is giving me which value? X or y? Huh? Y value, right? The equation is giving me y value. Where is the x value? Vp. Okay, so I'm looking for a y value. How much should be my Vp? Yeah, anything in this range. Anything in this range. Clear? Okay, so I can make a point 3 which has Vp between breakpoint and capacity, and then I will calculate S at Vp. Okay, so pick a value between breakpoint and capacity. Okay, for example, let's say my breakpoint is 1000 and my capacity is 2000. Okay, so I can pick a point between 1000 and 2000, that will become my Vp. I'll take this value, put it here, and find out the S value. Okay, so the value which you picked from the range will become your X, and the value which you will calculate from the equation will become your Y. Okay, so now you have 3 points. You can now draw the curve. Okay, you can draw the curve. If you want the curve to be more accurate, you can pick more values. Okay, in this range. Okay, in this range. We know the minimum, we know the maximum. Clear? Okay. Now, how did they draw this diagonal line? Remember, we are discussing these curves. You see diagonal lines here, right? Each diagonal line is representing what? What are these letters? Level of service, right? So how did they plot these lines? Level of service depends upon these values, and these values are for what? Density. Okay, density is flow rate upon speed. Density is what? Flow rate upon speed. Okay, do I have flow rate here? We have flow rate, right? Do I have speed here? We have. Okay, So if you do flow rate upon speed, it will become what? Density, right? And density can give me level of service. Okay, but if I do flow rate upon speed, what will I get? Flow rate is on the x-axis and speed is on the y-axis. If you do flow rate upon speed, which is density, so density is the inverse of the slope, right? What is slope? Y upon x, right? Slope is y upon x. Okay, so for example, what is the maximum density for A? 11, right? Okay, 11 is what? Flow rate upon speed, which is the inverse of the slope in this graph. Okay, which is the inverse of the slope in this graph. Okay, so if I do the inverse of 11, how much will it? How much is it? Zero point 0.09. Okay. Okay. Why I'm calling it tangent theta? Because it's a slope, right? You did what? Inverse of what? Huh? How did you get 0.091? Inverse of density. Okay, and density was what? Flow upon speed. You did the inverse, it became what? Slope upon, speed upon flow. And what is speed upon flow? Tangent theta. Speed upon flow is what? Slope, right? And slope is what? Tangent theta. Okay, so I will draw this line using theta from here. Okay, I'll calculate theta from here and draw this line. Okay, got it? If I want to draw the line for B, then what will I do? Tell me. I take the inverse of 18, that will become the tangent theta. And from there I will calculate theta and draw the line for B. Clear? Clear? Okay, any questions? How did we get what? I want to draw a line which is for level of service A. What is the maximum density for A? 11. Density is flow upon speed. If I go to the graph, it is the inverse of the slope, right? Flow upon speed is the inverse of the slope. So I take the inverse of 11, it becomes slope, tangent. Clear? Clear? Any questions? Okay, so we already draw the graph using those points, point 1, point 2, capacity, break point. We draw the graph and then we draw these lines. Okay, the point where these lines are intersecting the curve are called maximum service flow rates. So you already have a curve, then you draw these diagonal lines, and these, you can see these diagonal lines are crossing the curve, right? The points where these curves are being intersected by the lines, these are called as maximum service flow rates. Clear? Clear? Okay. For this question, our free flow speed is 65. Our free flow speed is 65. Do you see 65 here? So the curve is already drawn and the lines are already drawn. They already know the intersection points. Where are the intersection points? They are given here. Okay, so I know the maximum service flow rate of A, I know the maximum service flow rate of B and C and D and E. Clear? Okay. So if you look at the intersection point is the maximum for A, right? Or maximum for B. Okay. So if you are in front of the intersection point, your level of service is not A, right? For A, your flow rate should be less. Clear? Okay. Sure. Okay. Now these values, look at these values. What are the units? Passenger cars per hour, right? Okay. If I go to my question, okay, so these are my values. Do you see the difference now? What are the units here? Vehicles per hour. Okay, so there are three main differences here. What? These are two, right? What's the third difference here? So these values in the table are per lane. The values which I have are not per lane, so I cannot compare them obviously. The values which I have are vehicles. These values in the table are passenger cars, or in the graph these are passenger cars. Even if you draw your own curve, it will be passenger cars. Keep it in mind. This is default. The equation which you are using is in passenger cars. Okay, so all these values which are in passenger cars. So I cannot compare passenger cars with vehicles. Okay, so these are two differences. The third difference is what? What is the third difference? There is another difference. What was, you cannot see it properly here, but what was I calling this? Flow rate. And what are these values? Volumes. So again, you cannot compare flow rate with volume. Okay, so to compare the values which I have to the values in the table to know the level of service, I have to take care of three things: converting vehicles to passenger cars, converting volume to flow rate, and converting the total to per day. Clear? Okay, so each of these values, I will start with the first one, which was V0. It was how much? 3600. Okay, so it must be multiplied by peak hour factor. Multiplying by peak hour factor, we convert it to flow rate. Okay, so it will go from volume to flow rate. Okay, no, sorry, not divide. Okay, divide. So this will convert the volume to flow rate. Okay, then divide by number of lanes to convert to per lane. Okay, and to convert to from vehicles to passenger cars. Okay, we need the FHV value. Okay, FHV value, the equation is this. Okay, percentage of heavy vehicles given in the question, how much? Yes, how much is it? 10%. Okay, so percentage of heavy vehicles is 10%. EHV depends upon terrain. What did they say about terrain? Rolling terrain. Okay, rolling terrain, I have already shown you the tables. The EHV value is 3 for rolling terrain. So how much is this factor?
0.833.
Okay, clear? Okay, so now let us convert all these values to flow rate in passenger cars per hour per lane. Go ahead. So each value divided by the same factors. It's a 6-lane freeway. So how much is N? 3.
How much is the
How much is it? How much is it?
0.94.
9.
1.71.
Huh?
1.71.3. 0.5, sorry.
Okay, okay.
Two
2102.
one 2814. One zero four zero.
Okay. So now these values can be compared. They are now in same units. Passenger cars per hour per lane. Okay. Now I converted what? Volume to flow rate, right? I converted volume to flow rate. If I ask you to do the reverse, if I instead of converting these values, I can ask you to convert these values, right? So what will you do? If I divide it here, then I will multiply. Okay, all the factors, instead of dividing, now you will multiply them. Okay, but our purpose is to make them same, so you can compare. So either divide these values with the factor or multiply these values with the same factor. Clear? Okay, so we divided them, and the factors are in the same, the values are in the same units. I can compare them. Okay, look at the value for the current flow rate. Current flow rate is 1500 something. Okay, these are the maximum values for 65 free flow speed. Okay, the maximum value for A is 710. I already crossed it. It's 1000 something, right? Okay, I already crossed it. Did I cross B as well? Yes. Did I cross C? No. Okay, so my level of service is what? C. Okay, level of service at air 5. At air 5, I have 2100. Okay, so obviously now I'll cross C. I'll cross D as well. Did I cross this? No. So my level of service is E. Okay, air 10. My value is 2814. I've crossed this one as well. So now my level of service is F. Yes. And the remaining gears is only increasing. Only increasing. It doesn't decrease. Okay, so it will remain the same for the rest of the years. Clear? Okay. Any problem? Okay. Now the procedure which I explained for drawing the graph and drawing these lines, you have to do it in your term project. That's why I explained it in detail. Okay. I'm using these values because the graph is already plotted. If I had a free flow speed of 67, there is no 67 here. I have to plot the graph and make the lines, and then I will get the values. Clear? No, we cannot. Because it's a curve. You interpolate between lines. Okay, straight lines. Curve we don't. Clear? Okay. What else? Yes. Level of service F is between air 5 and air 10, right? Between air 5 and air 5 it was E, right? And air 10 it became F. So somewhere between them it became F, right? Can I know the air in which it became F? The air in which it reached what? After this is F, right? Okay. So can I find out the air in which it reached this value?
Yes, just
Huh? Interpolation, our favorite. Interpolation between what? Everybody wants to do interpolation. So we do interpolation in the graph. Okay, another brilliant idea. Yes. Huh? Okay. How do I calculate for 6 and 7? Yes. We are on the right track. Where? Where? Where are we changing? Which equation? Okay, let me make it simple. We change the volume. Which equation? N. Okay, we are trying to find out what? N, right? Okay, so I have the equation. Okay, you see the equation on the top. Okay, you can use this equation to find out N. Okay, so now my F value is 2350. Okay, I'm looking for the year in which this value was reached. My present value? No.
The year before.
You are asking for flow rate, right? So you will put flow rate. Okay, so the 0 year flow rate is 1571. Okay, not 3600. 3600 was volume. Okay, you don't know maximum volume here. Okay, so how much is N? Okay, so at the end of 7th year, it goes from E to F.
Where did we get the 1.06 from?
It was 1 plus I, and I is the growth rate, 6%. What? You are getting a different answer? You are getting no answer. Same. Okay. Clear? Clear? Okay. Now, if the level of service becomes F, how can I avoid it? What should I do? Increase number of lanes, right? Increase the number of lanes per lane will become less and level of service will be reduced. Okay, clear? Okay. Other things which we can do. Is these, okay? Increasing number of lanes is called as the supply management strategy. Okay, so you are building more roads. Okay, these are demand management strategies. Instead of increasing the space or lanes, you try to reduce the volume. Okay, try to reduce the volume. So, for example, you can cut down the volume by doing a different planning of the area. They call it zoning control. Okay, so when you are doing some construction in the area, you have to get the approval from the ministry and municipalities and so on, right? So they give the approval based upon their rules that in this area we will allow this many stories of the building, or in this area we can allow commercial, in this area we can allow residential and so on. Okay, so if an area only has maximum 5 stories building, and there's another area which can go up to 20 stories. So which buildings will attract more traffic? 5 or 20? 20, right? Okay. So if they control the zoning or the number of stories, the traffic will become less. Same thing with the type of building as well. Okay. You are only allowing residential here and you are allowing commercial and office and everything. So which one will have more traffic? The commercial. Okay. So if you control the zoning, you can reduce the volume. Another thing is provide them better public transportation, metro, good buses, and whatever. Okay, so the people will use less cars and more buses. So number of cars will become less. Second thing is increase or improve the alternate facilities. Okay, if you look at the Vision 2030 or 2050 of Bahrain, especially for the transportation sector, you will find that they are improving or building many highways for areas which already have major highways. Okay, what's the reason? So that the traffic is distributed. If you don't do it, in the future those highways which are now looking good, they will become congested and traffic jam will happen and so on. Okay, so they build parallel highways or parallel facilities so that traffic is distributed, volume becomes less. Next, the last point is what you may have already seen in the schools and educational areas, that different grades have different timings, right? Okay, now what's the reason? If people or kids from all the grades, they come together at the same time, obviously there will be a big problem in the school as well. Who can handle those kids? I cannot handle 2. So, but then there will be a problem of traffic as well. Okay, so many cars and buses which are coming at the same time. Okay, so this is called as staggered working hours. So you distribute the working hours or the opening hours of your office or your facility, whatever it is. So the pressure of traffic in 1 hour will become less. Okay, so peak hour traffic will become less. So all of them are demand management strategies, and they are helpful for reducing the volume instead of increasing the road space. Clear? Any questions?